Hello again. I guess this was a short break. We are still here, and we are here for yet another session that I will do together with David, and that is on color. So what is new in pdfToolbox 12 when it comes to color? So again, a couple of new features. And we will lead you through that. So, and again, we will play the game of changing the microphone here and there, and we will see how that goes. So first is more a recap, delta E based. So we had that in several sessions already during this event. So, but I thought, okay, I mean, a color session on pdfToolbox 12 can't just be silent on delta E comparison. So this is just one slide as a kind of recap in which areas of pdfToolbox 12 you might find that now delta E based comparisons. So first there is of course the interactive mode, the comparison feature in the visualizer, and then again in the visualizer there is the out of gamut feature where you can compare the file that you have with what would be the result when you color convert the file using an ICC based color conversion. And then there is, as David has just shown, the process plan step that allows you to compare a PDF file in a process plan with a previous version of that PDF file in the same process plan. So this is where you can use delta E. And then this is about next feature, updates to spot color name display. Strange feature. It's also under the hood, so no UI whatsoever in pdfToolbox 12. It works as part of an existing Fixup. Let me first just briefly describe the problem. So you create a spot color, let's say in InDesign or in Illustrator. You give it the name grün, which is the German word for green. And then you see a few other instances of spot color names that are using umlauts like Likör or Blasskönig, so all German words. And if you then create a PDF file out of that, then all the umlauts are gone and are replaced with somewhat unreadable exchange characters. And that frequently happens, and that frequently happens for a long time now. So, and the problem here is encoding. So what is used in PDF for spot color names is UTF-8 encoding. And so an engine that creates a PDF file better use that same encoding when creating the PDF file. However, that is not the case in the application that I have just mentioned. These applications are using platform encoding, and platform encoding, as the name says, is specific to the platform you're working on. So the platform encoding on a Mac would give you a different character code than the platform encoding on a Windows machine. And that means from our example InDesign file, we would get different spot color names, whether we would use the very same InDesign file, convert it to PDF on a Windows computer, or convert it to PDF on a Macintosh computer. And then on the receiving side, you have the difficulty if you get that PDF and you want to correct that you can't know on which platform that PDF file was created. So it's not easy to correct that problem. So since you just don't know what the character codes that you see was coming from a Windows or a Macintosh computer, and therefore you don't know how to interpret it. We have a fixup in pdfToolbox 11 already, that, or for a long time, not just 11, that has a name, convert spot color names to UTF-8. And that is used or is needed for some PDF-based ISO standard, because these, or some of them, require that no character codes may be used in spot color names or font names that are not in UTF-8 character code space. And this fix-up was just correcting that. However, it just made sure that UTF-8 valid character codes are coming out of it. And it was impossible to know which ones were intentioned when the PDF file was created. And we've improved that particular fix-up to have some understanding here. So what it does now, beginning with pdfToolbox 12, it looks as we made an analysis of various character codes that are outside of the ASCII limited character code space, and analyze what comes out of that when we convert the file on a Windows or on a Mac computer. And then we translated that, or we put that translation engine into this fix-up, so that we then are able, via this fix-up or in this fix-up, to replace the character codes with the one that probably were the ones that were intended to show up. So for instance, for a grün in InDesign, you would again get a grün when you convert that, when you use that fix-up on a PDF file. The limitation, as I've said, is there are certain codes that could come from a Windows platform as well as from a Mac platform. And then you don't know which one was used in the original. For this reason, we also implemented some words. So when the engine is capable of identifying a name, a word that is usually used for spot colors, like grün, for instance, which is frequently used because it's a color name, then we are able to identify this just by using the remaining characters, the G, the R, and the N in this case. And if that all fails, we give the Macintosh platform priority, since we believe that still most of the pre-pressed PDF files are created on Macintosh. So if the engine can't decide otherwise, then we would use MacRoman encoding, which is used on a Macintosh. Lots of explanations. I hope that it will just work for you, so that this is just some background information if you would like to have that. And then there is a question.
So there is a question from two people, same question. CC exports spot colors with platform encoding instead of UTF-8 encoding. So CC is not generating a compliant PDF X4.
I mean, it depends. So because they are not saying that it's platform encoding. So they just give you a number of character codes. And only if these character codes would the codes would be outside of what can be used in UTF-8, it would be an invalid name. However, as far as I know, this is not the case. So they are valid PDFX files. The names just doesn't often make sense if you're outside of the ASCII characters. Does that make sense? More questions? Okay, then it's all gray.
So this is about images, and specifically images, although it's in theory it could be applicable to other objects as well. But the question usually comes up when people talk about converting images. And the question is, if you have a conversion of a PDF file and you're going to convert, or you want to convert a whole file to CMYK, regardless of what type of CMYK, you might have content that says it is CMYK or says that is RGB. So I might have an RGB image in there or a CMYK image. That means that it's encoded as CMYK or encoded as RGB. But if you look at it visually, or if you would analyze the pixels, you would see that it only has grayscale content. So it's a neutral, completely neutral image. Yeah? And so it would have been smarter if it was encoded as grayscale, because then it would be smaller and we wouldn't have to convert it if a conversion to CMYK happens here. So what you want to happen ideally is that you want to convert all the objects in the file to your CMYK space, but these things that are actually gray should either just not be converted or they should be converted to grayscale. And the question is, how do you do that? And there is a way to do that now in pdfToolbox. There is a condition that you can use to make a check. And that condition is called difference between colorant channels. You can see it there on screen. And it returns a number. Yeah? And this condition works for RGB and CMYK objects. And for CMYK objects, if you think about this, that's logical. It only looks at the CMY channel. So not the black channel, but the channels that define color. It doesn't only work for images. It also works for vector and text. But like I said, the major application of this would be images in all likelihood. And it returns a percentage value. So if I return to this condition for a second, the number that you see there, I have set it to less than 1. What that actually means is that the maximum difference between the different colorants in that image, for example, the maximum difference should be lower than 1%. And of course, this can be used as the input for a color convert fixup. Color convert fixups have these apply to fields, and that apply to field determines which objects are going to be touched. So in a color convert fixup, you could say, look at all the images, convert them all to CMYK, except for the images that are this faux gray. Yeah? Or the other way around, and there are two new default fixups in pdfToolbox 12, you could make a color conversion fixup that converts only those gray-looking images to grayscale. And then in the next step, for example, you could convert everything that is now left to CMYK, and that would fix the problem. So if you've been in a situation where you needed something like that, look at the two new fixups that you have in pdfToolbox 12, and that should help significantly in such workflows.
Yes. Now we add undercolor white. How does it go and why do we want to do that? This feature is for anybody, everybody who wants to print on transparent substrates, on a foil or so. And if you do so, you often need to preprint white on that foil, because as in this example here, some areas of the subject of the PDF page are supposed to be white while others are transparent, and then you want to display white here. And also where colors are bright, where you just have little color that is being printed, you just need the white in order to give some backing to the color so that the transparent foil, or what is behind the transparent foil, doesn't shine through. However, you wouldn't actually need white ink where there is lots of color. So in this example, I'm not sure, I'm not an expert here, but in this example, I would assume, since there is so many red, I would only need the white background where there actually is text. I wouldn't need white background behind the red. And then, given the fact that white is the most expensive ink that you can purchase, there is a requirement actually to save as much of this ink as possible. And that means you would want to have a print form for your white printing device that gives you only those areas of the page where white is needed. And then, in theory at least, that could be based on an ink amount check, because that will let you know how much ink is used in the other colorants, and then you can derive a white form from that. So as I've said, in theory, you could do that, and beginning with pdfToolbox 12, you can also do that in reality in pdfToolbox. There is a new Fixup which has a name Create Spot Color Plate based on ink amount, and that basically does what I've just said. So it has a number of parameters, as you can see. Most importantly, it lets you define a spot color name and also some alternate color here for that spot color, which is 50% cyan. So that you just display or able to display something. Then the resolution that you would use in order to calculate the ink amount. And then most importantly, it has a mapping curve that maps ink color, color values, so ink amount values, to result color values for your spot color. So this mapping curve is the most important ingredient to our process. There is one more thing, so you could also exclude objects here from the process. Yeah, exclude objects. So for instance, whenever that makes sense, you could also say, okay, I only want to do that for areas of the page that are text or whatever. So you can, again, works like an apply to, you can again use any filter here. But back to our setup here. There is, as I've said, there is a mapping curve. And I have here a screenshot from one of the by default installed mapping curve that shows how the whole thing works, I believe. You have starting with 0. So wherever the ink amount in my original file is 0, so there's no ink at all, I don't want to back that with white. So I don't want to have white there, because there the object should be transparent. And we will get back to that there are exceptions to that rule later on. But for now, and for our object, for the print job that we currently have, this is the right setting. And then if there is no input ink, yes, then we are at 0. If there is high output for, if there is a low input, low ink input on the input file, then I need high output. So if there is low ink on my incoming file, I want to have the full 100% of white in the background. And the further I get, so the more ink amount I'm getting in my original file, the fewer white I would want in my result file. So let's see how that works. At least this is lots of theory so far. So I've got an example here. An example, and we just assume we want to print this on a transparent foil, and what we want to see is a result file where we have few white here in these rather dark areas, but lots of white in these rather bright areas. So, and then there is a predefined fixup for that also demonstrates how the whole thing works. That has the name create white underlay for print content on transparent foils. And then I'm saving it into my result folder. I've tested that before, no surprise. And now I've got something blue here, and then I can use my individual separations view to see what I've gotten. So, and I have a new spot color here, which has a name white underlay. And if I display only that, I have gotten exactly what I wanted to have. So in this dark areas of my original files, I have just a little bit of this spot color. And in the lighter areas of the original files, I've got a lot. So I can switch to the original file here, regular page view. And then it should actually switch to the regular page view. Yeah, here again. And we see the blue here still in front of it. I could also go to process separations. So this was the original file. Okay. Yeah, we can maybe should also look into that. So we just see it. Here is a spot color name, white underlay. It has an alternate color value, 50% cyan. And here is my sample curve. And the sample curve, as in other places of pdfToolbox, is a curve file somewhere, and I can have access to that file in the file system. If I click here, it opens the folder where this and another curve sits. Okay. So going back, this is not the end of it. So what happens if I now have the very same label? However, here in this instance of it, it doesn't use yellow in this area or in the text here. It uses white. And then that is actually a frequent thing in a PDF file that is going to be printed. There is a difference between transparent and white. So here I have white, and white definitely needs white background, while transparent doesn't. And in my label here, I have the thing here, white, is different from the white outside of my label. So I wouldn't want to have white background outside of my label, but I want to have white where my original file has a white object, either white text or this white vector graphics, vector element. And as you maybe know, there is a shape feature in pdfToolbox that actually can do that. So in the shapes feature, you can say, give me a shape of all objects on the page, including white objects. So there you can be specific about whether you want to include or exclude white objects. And for this reason, there is not just a predefined fixup, there also is a predefined process plan in pdfToolbox 12, which says white underlay for print content on transparent foil, which exactly does so. So it uses a shape in order to determine where you want to have white background. And it still uses the curve function in order to take the ink amount into account. And that's what I wanted to say for this one, but I'm open to questions.
There is a question, are the input values per channel or combined CMY?
Combined. So this is ink amount, so it takes all other colorants into account, not just CMY, also black and also spot colors, whatever comes in. So it's the total ink amount. If you want to exclude something, that is possible. So I've shown you that it's possible to exclude objects or colorants, but normally it would use all colorants combined. Okay. Now you.
Okay, so this is a relatively small one. I think we mentioned this in another session as well, but because this is about color and all the things that have to do with it, we wanted to make sure it was mentioned here too. The topic is the apply to filters, and specifically when you have convert page content into image. In the previous session, we talked about this Fixup as well, because you can use it to take a file and then convert the pages in that file into an image. So the input file can contain all kinds of stuff. The output file will contain still the same amount of pages, but on each page you will only have one image. The question, if you want to do that, is that's all good and fine if you want to just convert the whole document to, well, every page in the document to an image. But typically that's not what you want. For example, you might look at which pages do I think are very complex, using the number of objects on a page, for example. You might look at other parameters and then decide which pages you want to convert into an image. And the Fixup has an apply to filter for that. So if you look at the second property there under image resolution, that is an apply to. It's called apply to pages, and by default it says all pages, and that one can be used to determine which pages you want to convert. And then in previous versions of pdfToolbox, that's where it stopped. You could have only one apply to filter in a Fixup. They all had only one, and so you could choose which pages you wanted to convert, but that was it. Unfortunately, very often what you want to do is not just control which pages you want to convert into an image, but also have some control over which objects do I want to put in that image. Because maybe there is some text on this page and you know that the document will support leaving the text live and then rasterizing everything else. And in pdfToolbox 12, there is now a second apply to filter, and you will, where is it? Accept page objects, so the second property from the bottom. And that one determines which page objects are not going to be converted into that image. So if I would set that to a pre-flight check that says, by default, it's what it has here, none. So everything is converted. If I would make a pre-flight check that says detect text, then all the text in my document is going to remain live, and the rest of the page objects are going to be put in that image. Yeah. So that allows you to control that. It's a small thing. It's not a really new thing. Apply to filters have existed for a long time. It's just that now in pdfToolbox 12, you have the ability, or the engine has the ability to have multiple apply to filters, and you see that used here. And there is at least one other Fixup that uses that as well. And I forget which one it is. Okay, so you did white, then I think you shouldn't discriminate and you should do black as well.
Right. So turn David to rich David? No, turn black to rich black. So what is that and how easy can that be? Let's see. So yeah, it's actually also a short one and it's fairly easy. There is a new Fixup which has a name setColor. And I first want to describe to you how that works because I think the concept is really easy. It uses an apply to filter, and we just heard what that is. It's just a check that can identify objects or pages, but in this case it's objects. So it would find any number of objects, and this number of objects would all get a new color. So any objects that are found by this check would now get a new color, and then that color could even be a spot color. So, and then you can use that, you can use this new Fixup setColor in order to convert black to rich black. So if you set up a check that would find all black objects in a PDF file and then just give these objects a new color, as in this example, 40% cyan and 100% black, then you would end up with all black objects in your PDF file being converted to rich black. And for this purpose, and this is a frequent requirement as I've heard from large format. So in large format, most of the time black is not printed as pure black, but it's always or most of the time combined with additional color from other colorants. Therefore, there is a predefined fixup in order to do so, which has the name black to rich black. And that's it. It wouldn't be, I don't want to show this, and it wouldn't be very interesting to see that because you can't see rich black on a screen. So you have to try it out yourself. Which brings me to the last feature that we want to introduce in this session. I don't know, if there is any question related to that, please just let me know. Otherwise, I will move on to the next feature, and that has to do with transparency flattening. And that is just background information. So basically in the UI, you won't see anything. It's just so that something behind the scenes has changed, and we just wanted to mention that to you so that you know. As usually in new versions of pdfToolbox, in major versions at least, we update the internal Adobe PDF library that we're using. And this update, in this case, created some problems when it comes to transparency flattening. And there, in order to explain that, I need to explain a little bit about the background. So what the transparency flattener does, it often has to create new objects. So I have two objects that overlap with each other where the object in front is transparent. So what the flattener does, it creates a new object where the two objects overlap with the result color of the transparency effect. Whenever the flattener does it, it has the habit of creating it as ICC-based color. So even if you have a CMYK, purely device CMYK page, it would introduce ICC-based CMYK objects. And these objects are often not wanted in pre-press production. And up until the recent version of the Adobe PDF library, it was possible to just globally decalibrate all ICC-based CMYK objects, because the transparency flattener at the same time had the habit to color convert any other ICC-based CMYK object on the same page into their destination color space. So, and therefore we introduced a checkbox, a setting into our implementation of the transparency flattener that allowed you to specify whether you wanted to decalibrate all CMYK objects after flattening. Let me just add, and in this place, it is impossible for us, for our engine, to identify which object had been there in the beginning and which object had just been introduced by the transparency flattener. So now the transparency flattener is somehow improved so that it keeps more ICC-based CMYK color alive when it does transparency flattening on a page. And that requires our engine to identify which objects had been created by the flattener in order to be able to only decalibrate those objects. And that, exactly that has been implemented in pdfToolbox 12. So it was some work, it was some testing, but we think the results are better than before. And yeah.
There is a question about previous slide of yours, not the slide, but when you were showing set color Fixup, I think.
Yeah.
Yes. So the question is, how does this color conversion interfere with other color conversion in the same profile?
Usually, I guess, probably the question is which comes first? Usually, I think, I'm not sure. I think mappings are, this is part of the mapping engine, so the color mapping engine, which is different from the color conversion engine. Color conversion is ICC-based color conversion, mapping is color mapping. And I would assume that mapping comes before color conversion. But I'm not fully sure, but we can easily find out and get back to you who have asked these questions after the session. If you want to be sure, of course, then the way to solve that would be a process plan. So in a process plan, there you have control about in what order color conversions are executed. And there is no way, so when it comes to color conversion and you need to perform several color conversions on the file in one go, there is often no way to avoid using process plans.
So that's what I just wanted to add actually. When I give training on pdfToolbox, when I tell people, if you start wondering which thing is going to be done first, you shouldn't be doing it in a profile. You should use a process plan. That's why it was invented. And that way you're certain and you have control.